We will try to solve this ladder problem in 3 different ways. The ladder is resting on a floor, smooth floor, and is leaning against a smooth wall. The top of the ladder is sliding downwards along the smooth wall at a velocity of 1 meter per second. H is equal to -1 because it is sliding downwards. So we will keep the direction upwards as positive and downwards as negative. What is the velocity at which the bottom of the ladder is sliding along the smooth floor? We can find the direction also by using the sign for H. Okay. Now we are going to use 3 important properties. One is this ladder property. The ladder length L is going to be constant, and Pythagorean identity, the ladder length is given by the square of the ladder length is given by sum of the squares of the opposite side and adjacent side. This is the Pythagorean identity. And L squared is going to be constant because L is constant, and therefore differential of L squared also is 0. Right? Differential of L is 0, therefore differential of L squared with respect to time also is 0. And then we are going to find out the differential in terms of partial derivatives, and chain rule is used. Chain rule is given by differential of L with respect to t is differential of L with respect to x into differential of x with respect to time plus dou L by dou y into dou y by dou t. Please note I have used dx by dt and dy by dt because x is a function of only time, y is a function of only time. If it's a function of something else also, some other variable also, then I have to use dou x by dou t and dou y by dou t. There it is, dou L by dou t. Because L is a function of x and y, I am using partial derivative with respect to x, keeping y squared as constant. Here I am differentiating this to y, keeping x squared as constant. So we will try to use these 3 things and then try to solve the problem. Now, diagrammatically, I am representing this ladder, wall, and floor. And I am replacing this by a triangle where L is constant and L is equal to L squared is equal to x squared L plus y squared L, and h is the velocity downwards, u is the velocity, right? Now we will use the Pythagorean identity. This is though this is the identity, I will use L squared only because xl squared plus yl squared is equal to L squared. This is also a constant, therefore it is easy for me to differentiate this. And xl and yl being varying with respect to time because it is sliding down, so yl will keep changing, xl will keep changing. I will replace xl and yl by x and y. And this is the relation, I'll be using it. And I'm going to differentiate and get the answer. So I will use the chain rule before that. Chain rule is, I've already explained. And differentiating L squared with respect to t is 0. Differential of L squared with respect to x, because L squared being x squared plus y squared, keeping y squared as constant, differential is 2x. And dou x by dou t is u. So 2x u. And so I'm differentiating here. So L squared, differential of L squared is 0, differential of x squared is 2x, and dx by dt is u, and differential of y squared is 2y, dou by dt is equal to 0 here. You can see this, previous relations. Differential of L squared with respect to y is nothing but differential of y squared with respect to y, dou by dt is 2y, dou by dt. Dividing throughout by 2 and replacing the instant time. Dividing throughout by 2 means 2 cancels. Here also becomes 0 only. And replacing x by xl and y by yl and dou by dou t by h and dx by dt as u. I'm just substituting x as xl, dou x by dou t is equal to u, y as yl, and then dou by dou t as h is equal to 0. Now I'm getting a simple relations. All I need to do is substitute the value with sign. I'll get the answer with direction. Now, this simple relations I am going to use for solving the problem. I am given a problem where xl is equal to 6 meters, yl is equal to 10 meters, h is equal to -1. I simply have to substitute to find out the answer y. Y is equal to minus yl h by xl. Minus of yl is 10 divided by xl is 6. So minus 10 by 6 into h is -1. Therefore, plus 10 by 6, 1.67 is the answer. I thought I did correctly and gave the answer as 6 and failed in check test. Okay. It just happens to anyone, and that is mathematics. We will try to solve it by 2 other methods here. Another method is here. I am going to find out the relation for the straight line. I am not for the ladder, because the straight line has a slope is kept constant. Slope I am finding out by this point, coordinates of this point and coordinates of this point. Coordinates of this point is 10, 0, and coordinates of this point is 0, 6. So 10, 0 and 0, 6. So I'll find out the slope as y2 minus y1. This is 10 by minus 6. So 10 divided by 0 minus 6 is minus 6. Therefore, minus 10 by 6 is the slope. And for this relations, differentiating, I get dy by dou t is equal to slope is constant minus 10 by 6 dx by dt. Substituting dy by dt is equal to minus 1. I am getting dx by dt is equal to 6 by 10. Right? Please note that it is a reversal of this. If it is dy by dt is 10 by 6, it is 6 by 10. Yeah, that's the thing. And now, please note I am keeping the constant slope. Therefore, this is not the problem, because we know that if the constant slope is there, if it decreases, this also will decrease. But I am going to keep the lateral length same. Therefore, allow the slope to vary, and therefore the answer becomes the reversal of this. Therefore, dot square root is 10 by 6. You will be able to appreciate this much better in my third slide. If I remember, probably I will be able to point out that also at that time. Right? Now, we will try to see the answer by the third method. Here, I am not going to use any time factor at all. Infinitesimally small time, not unit, but infinitesimally small distance also. Right? If it is 1 meter per second, I have to take it as 0.0001. The difference, I have to say. So, if it is 1 meter per second, I am not going to substitute 1 because I will not get the right answer. I have to substitute 1 by thousands. Right? If they are given 2 meters per second, I have to say 2 by 1000 and then find out the corresponding value and then revert back to 2. And you will see this here in the next slide. So I'm using a Excel sheet here and I'm giving the change in y as 0 to 10 because when the change is 10, y becomes 0 and x becomes 11.661. So I am finding out the lateral length using the y and 6 given and retaining the same thing so that I get the accuracy. Right? So once I change this height from 10 to 1, because they have given 1 meter per second, then the height becomes 9 meters per second. Therefore, I will find out the revised distance by using the relations root of L squared minus y squared, root of 11.6619 squared minus 9 squared, which is 7.416. Please note that the change in x is 7.416 minus 6 is 1.416. Now they have given the value of delta y is 1 meter per second h, right? In our question they have given it as h, I have taken it as delta y. Therefore, delta x is 1.4167. Same thing using this formula, right? So for 2, it is 2.418. So for 2, it is 2.41485 means for 1 it will be 1.246. But the answer we got for 1 is 1.667. How do I get these things? Therefore, what now I do is I take in cows, 1,000, that is 0.0001. Then the change in length becomes, change in distance becomes 6.000167. That is from 10 to 9.999 I change. Then the distance increases from 6 to 6.000167. Therefore, for a delta y of 0.0001, the change in x is 0.000167. Therefore, for a given value of 1 meter per second, I just have to take it as 1 divided by 0.001 multiplied by 0.00167. The answer is 1.667, which is the same as the value that I got here. Right? Now, if the problem is h is equal to 2 meters per second minus, if I substitute here, what will happen? I will get 3.33. Because minus 2, I have to substitute 3.33. How do we get it? The answer, we will see in the method here. So, suppose I give, in the next slide, I will put it here also, I will put it here. 0.002, it is 0.0003. Because if I change the distance by 0002, then 10 to 9.9998 comes. Then the corresponding distance is 6.00033 and the change in distance is 0.00033 for a delta y of 0.002. Therefore, for a change of y is equal to 1, the answer is same. So if I take a very small infinitesimal value, but I am getting for 2 meters per second, it is 0.330. So if I substitute 2 here, it will be 3.33. So this is what I have shown here. For a change of 0.002 here, 0.998 here, the y becomes 0.998 and the distance becomes 6.00 using the relation square root of 11.6619 squared minus 9.998 squared is equal to 6.003325 and the change becomes 0.003325. If the value of h is given as minus 2, then I give it by proportionately this 2 here, 3.325 here. Multiplying by minus 2 divided by minus 002 0.002 into 0.003325 becomes minus 3.33. Okay, that solves the problem. Thank you very much for watching. In case you have any queries, please let me know. Right? I'll be happy to share with you and share with you in the next slide. Okay, thank you very much.